Okay, so hello and welcome to this video tutorial for E411 Statics and Dynamics of Simple Mechanisms. So we have this problem here. It states, write the equations of motion in the x and y directions for the 10 kilo block. I'm not the biggest fan of this question, just in terms of the way it's worded. It says, write the equations of motion, as if the equations of motion are just this kind of preordained thing that we're supposed to understand prior to going into this problem. I would rephrase it and say, the question should say, describe the motion in the x and y directions for the 10 kilo block. Okay. And if we're going to describe the motion of this 10 kilo block, it might first make sense to understand the forces and the resultants of the forces acting on the block. So if we're trying to understand that, we might start, as we typically do, by drawing a free body diagram. So I've kind of made a start here. So we've got this 10 kg weight, or this 10 g weight. We have this normal force with the surface, or the slope. Come on, Microsoft. There we go. And we've got this frictional force that is acting against the block as it slides down the slope. Okay, so an important thing to notice about this problem is this x and y directions kind of idea, where y in this instance isn't y as we might typically know it, where it's just straight up. Rather, the y direction in this instance means 30 degrees to the vertical, and the x direction in this instance means 30 degrees down from the horizontal, right? So we want to understand the forces acting in these directions. Let's start with the y direction then. So f of y, I may need to kind of slant my head to try and look at this diagram as if, y is up and x is horizontal. So if I want to consider things acting up, I've got n. If I want to consider things acting down, I've got this 10, the y component of this 10g force here, which I can describe as 10g sine 60. If you're unsure where the 60 comes from, notice that the x direction here looks like this. We could kind of understand kind of a right angle triangle here. So you've got a 30-degree angle here. You've got a right angle here. So here you must have a 60-degree angle, since all the angles add up to, in a triangle, add up to 180 degrees. Okay. Presumably, because this block isn't falling through the slope, or isn't falling down in the y direction, and it isn't floating up into the sky because it's a balloon or anything, we can assume then that the resultant force in the y direction is 0. Okay. Is this solvable then? Well, yeah, because there's only one unknown. It's just this m here. So we could say that therefore n is equal to 10g sine 60, which when I bung into my calculator, that gives me 49 root 3. Okay, so we found the value for n. What can we say about its motion in the y direction? Well, we can say, for example, velocity in the y direction is equal to acceleration in the y direction, which is equal to 0. It's not moving up or down in the y direction, is what we're describing there. Okay, let's consider the x direction then. So sum of forces in the x direction. Again, I had to slant my head. Things moving to the right. we could say that that's the x component of this 10g force, which we can describe as 10g cos 60, and this point 2 n acting to the left, I'm going to describe as 0.2 times 49 root 3. And when I put this into my calculator, I find that the sum of forces in the x direction are equal to 32. Now, maybe I should just write that up here, actually, equals 32, 0.0. So understanding this idea that the forces in any given direction are equal to the mass of the object times the acceleration in that direction. Okay, so in this instance, we're considering the x direction. We can say, therefore, then that 32 is equal to the mass of the block, which is 10 kilos, times its acceleration. And then we can therefore say that its acceleration in the x direction is equal to 3.2, since 32 divided by 10 is 3.2. Okay, so there we have it. We've described its motion. You could potentially describe its motion further. You could say we're going to assume that it starts from rest. V at t equals 0 equals 0. There's not much more we can say about the motion of the block at this point.